Hello ladies and gentlemen, and welcome back to our Distance Learning Algebra 1 lesson, again here with Mr. Hagedorn. Today we're going to talk about Lesson 7.5, Factor Special Products and Factoring Completely. The first example that we're going to take a look at here today is when we are factoring the difference of two squares. Obviously, in order for this to work, they have to be subtracted, and both of the terms have to be perfect squares. If that does work out, as you can see here in the middle of the page, the algebraic way of doing it is to take the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So to factor the example that we have here for our lesson would be to take the square root of x squared, which is x, and then add to that the square root of 64, which is 8. And then we take times that, its other binomial, which would be the square root of x squared minus the square root of 64. So it's a very basic way of factoring, but the stipulation here is that you're subtracting and both of the terms are perfect squares. The next example that I have here for you, ladies and gentlemen, is factoring a perfect square trinomial. Now, in order for a perfect square trinomial to be perfect square, it has to follow the following patterns. It either has to be a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. In other words, the first term must be a perfect square, which in this case x squared is. The third term must be a perfect square, which in this case 64 is. And the middle term has to be 2 times the square root of the first times the square root of the third. The square root of x squared is x, the square root of 64 is 8, and 2 times 8 times x is 16x. So if you notice that, then the way that we would factor this type of a trinomial is it becomes the square root of the first term, the sine of the middle term, and the square root of the third term, that binomial squared. Now, if you don't recognize that that was a perfect square trinomial and you factored it just like we talked about in lesson 7.3, factoring basic factors or basic trinomials, you'll get the same exact answer. Either way will work. This is just a shortcut or a way of doing it. And as you can see down here at the bottom of the page, there are a couple examples that would go along with what we just went through up above. So continuing, now we're going to get into some of, I guess you just call them more unique algebraic ways of factoring. The example that you see here is actually a step in the process that we learned in 7.4 with the British method, and that's once you get to the point where the binomials are the same, they become the first factor. So in this case, since x plus 2 is the same in both, we factor that out. That becomes the leading term of our binomial factors. And then remember, if those binomials are the same, the terms that are out front become their own binomial, which in this case would give us the second part of our factored answer, 3x plus 2. But again, remember, in order for this to work, the binomials that we see there in parentheses must be identical. If they're not, then this type of factoring won't work. So now we're going to factor by grouping. Now, if you remember from the lesson that we dealt with in 7.4, factoring advanced trinomials, what we have here is that grouping part. Once we get it, we split it apart, we took the middle term and rewrote it, now we can group. Now this one isn't exactly like what we looked at in 7.4, but it does follow the same process in the grouping. So the first two terms that we have here, we group together, and the second two terms that we have, we also group together. So the first two here, if we look to factor out the greatest common factor of each one of those, in this case it would be x squared. If we factor an x squared out of both, that would leave us with x plus 7. In the second terms here, we have 5x and 35. In this case, the only thing we could factor out of both those, the greatest common factor, would be a 5, which would leave us with x plus 7. Now, like we just talked about on the previous screen, this is the point that we'd like to be at. Notice the binomials x plus 7 are the same in both. So because of that, that becomes our first term of our answer, x plus 7. Then the terms that are out front, or the terms that we factor out as greatest common factors, become the other binomial when combined, which in this case would be x squared plus 5. So again, it's very important that you remember the order of the grouping, first two, second two, and that the only way that it works is once you factored out the greatest common factor, if the binomials that you have left are identical, then you are good to go. All right. And now the last example that I have here for you is an example that's not going to show anything new as far as types of factoring, but it's going to show you an example that in some cases you may have to factor more than once or use more than one factoring method in order to be able to do it completely. So if we take a look at this, it doesn't really look like it's anything that we would be able to do just by jumping into it. So if we look at it, one thing that I notice is each one of them has a common factor that we can factor out. So the first step of this process would be to factor out the greatest common factor. This is no different than anything we've done before. It's just doing it now with something that we haven't seen before. So in this case, the greatest common factor is 4x. If we factor out a 4x, that would leave us with x squared minus 11x plus 24. So now by factoring out our greatest common factor of 4x, that leaves us with a trinomial that we can now take a look at and say to ourselves, can we factor that down? Recall from 7.3, we're looking for the factors of 24 that when added together give us negative 11. Quick review with that. If your middle term is negative and your third term is positive, that means the factors that are going to go along with in the binomial are both going to be negative. So what factors of 24 when added together give you negative 11? The answer is negative 8 and negative 3. So our final answer for this, or our final factored form of it, would be 4x times the quantity x minus 8 times x minus 3. So that, ladies and gentlemen, is just a quick overview of factoring special products, factoring special polynomials, and then making sure that in every situation we factor completely. Ladies and gentlemen, if you do have any questions on this, I look forward to talking to you about it in class. Otherwise, make sure you take the time to take a look at your practice worksheets. If you do have questions on those as well, please bring them to class next time that we meet. Lord's blessings on your day, ladies and gentlemen, and have a wonderful day.